Welcome to College Algebra. We're going to do a little mini unit to start the course. Lessons 42, 43, and 44 are sort of a unit unto themselves. The topic is going to be absolute value inequalities. That's where we're heading for in section 44. And what are those? Those are where you have some kind of stuff, some kind of algebraic stuff, x squared plus whatever, who cares what the stuff is. But the stuff is maybe less than something or maybe greater than something or whatever. The application that I mainly see, or that I have mainly seen in my experience, is like a lot of error analysis or sensitivity analysis or something like that, where you need the quantity to be smaller than a certain amount, but you don't care if it's positive or negative. You just care that its absolute value is smaller than a certain amount. Get it? Absolute value. There's the link. Or it could be that you need it to be at least a certain size and you don't care if it's positive or negative. That would be one of these deals. You need it to be at least a certain size. This number could be whatever. And you don't care if it's positive or negative. Hence, you put it in absolute values and say, I don't care if it's positive or negative as long as the magnitude of the thing is greater than 5. Anyway, error analysis, sensitivity analysis, this stuff does happen. You'll probably see it in some lab report somewhere in your future. But the main reason I want to start with this is not the real world application. I want to start with it because I think it's a great opportunity for us to kind of get back in the swing of things, taking x's and swinging x's around. And not just swinging x's around, but swinging x's around carefully. Always thinking about what did you just write and being critical. Does that make sense, what I just wrote? And if what I wrote is true, what does that actually mean? And so on. You got to be careful with this stuff. Anyway, let's get started. So we're heading towards absolute value inequalities, like I say, but we got to start with the simpler case of equations in order to get there. Absolute value equations, what are those? They look like that. You know, there's a simple example of an absolute value equation. And I'm going to ask you to solve it just by looking at it. Ask yourself, what is this number? What is this x? If I know that the absolute value is 5, then what is that number? Okay, so you see what's going on here. It's after you strip the sign off, the x, because that's what the absolute value does, it strips the sign off. After you strip the sign off the x, it's a 5. And so that means that the x itself could have been a plus 5 or it could have been a negative 5. Because either one of those, if you take a 5 and you strip the sign off, it's a 5. And if you take a negative 5 and you strip the sign off, it's a 5. Right? So it's after you strip the sign off, it's 5. Oh, really? So before I strip the sign off, it might have been plus, it might have been minus. I don't know. Before I stripped the sign off, it was one of those. And so you end up with 2 solutions. And we're generally going to have 2 solutions to these things. Now, that's kind of the key idea. Look at this thing for a second and ask yourself, what is x? You might try doing it in your head just by making up numbers, plugging them in to see if they work. But if you want to be a little more methodical about it, what you can do is you can say, well, using the same logic, after you strip the sign off the what? Not the x. Off of what's inside here. Off of the x plus 3. You get 5. Okay. After you strip the sign off the what's inside. After you strip the sign off of the and you group it. You're trying to consider the whole thing as a single object, so I put it in parentheses to group it to make that point that I'm treating this as a single object. This x plus 3. This x plus 3. I strip the sign off of the x plus 3. And I get a 5. So taking a page from over here, that means that this x plus 3, before I strip the sign off, it might have been a plus 5 or it might have been a minus 5. See how similar this is to what this is. The stuff inside could be plus 5 or it could be minus 5. So in this case, we're basically getting 2 equations to solve. We're going to get 2 answers because we've got 2 equations. So one equation says that x plus 3 is equal to 5, and the other equation says that x plus 3 is equal to negative 5. And you solve these up real quick, subtract 3 on both sides. That's telling us x could be 2. This is telling us x could be a negative 8. And if you check those, you should find that it really will work. If I put a 2 in here, what have I got? I've got a 2 plus 3 is 5. You take the absolute value of 5, you get 5. That worked. Okay. Let's put the negative 8 in there. If you put the negative 8 in there, you've got the absolute value of negative 8 plus 3 which is a -5, and when you take the absolute value of -5, you do indeed get 5. So both of those solutions work. So this is going to be our basic method. You take the stuff that's inside the absolute value here, the stuff, and you say, well, after I strip the sign off, it's a 5. So before I stripped the sign off, it could have been a +5 or it could have been a -5. Okay, so you end up taking your one equation, it becomes two equations. Removing the absolute value bars has the effect of turning your one equation into two equations. Okay, so our basic strategy then, we're going to use this idea, of course, but our basic strategy, if you have a more complicated equation, like this one's a little more complicated, right? Our basic strategy is to, in order to apply this logic up here, you really want to just be looking at an absolute value on the left side. I don't care what's inside the absolute value, but I do want to just have an absolute value all by its onesies on the left side. Do I have an absolute value all by its onesies on the left side? No, I really don't. So my first thing to do then is to actually isolate that absolute value, and that's what this is saying. First, isolate the absolute value of whatever stuff. Then we can start applying that idea of before we strip the sign off, it must have been plus or minus that, blah, blah, blah. So, trying to get this thing by itself. Now, I know that you've solved equations that look like this, right? This equation doesn't really look so different, really. It's just that instead of having a simple x, we've got a blah. But the structure is exactly the same. So we're going to solve it in exactly the same way. Namely, how would we solve this equation over here? You'd say, well, first I got to subtract 8 on both sides, right? I'll have a 4, and then I'll have to divide the coefficient off on both sides, and I'll get a 2. That's how you would solve that equation. How do you solve this equation? Same steps. You want to subtract 8 on both sides. That's the first thing to do. So the term that contains the absolute value, I get that by itself first. 12 minus 8 is 4. Then you look at this thing and you say, well, I'm trying to get just this part by itself. I don't want a 2 multiplying it. How do you undo a times 2? You divide by 2. Divide both sides by 2. It'll cancel over here. So now we've got absolute value 3x minus 6 is 4 over 2 is 2. See, that's the thing. That's what you want to do first. Isolate the absolute value of the stuff. Do that first. Whoops. Do that first. What I do? Come on, you. Do that first. Okay. Then we apply the logic, the basic idea that before we stripped the sign off, this thing could have been a +2 or a -2. After we strip the sign off, it's a 2. So before we strip the sign off, it could have been a +2, it could have been a -2. We've got two equations here, folks. So one equation is 3x minus 6 equals the +2, and the other equation is 3s minus 6 is equal to the -2. Add 6 on both sides, I've got an 8. Divide both sides by 3, I've got an 8/3. Cool. This one, add 6 to both sides, I got a 4. Divide both sides by 3, I get a 4/3. Cool. So there's my two answers, 8/3 and 4/3. P.S. We love improper fractions in this course. Don't worry about taking 8/3 and saying, oh, that's 2 2/3. Don't worry about taking 4/3 and saying, oh, that's 1 1/3. That doesn't matter. Now, we do want them to be reduced, always reduced. So in other words, if you had come out with an 8/6, you wouldn't leave it that way. You'd cancel the 2's and say 4/3. So always reduce, but we didn't have to reduce here. 8/3 is reduced, 4/3 is reduced. We're good. Okay, so just leave them as improper fractions. Certainly not decimals, and you're going to hear me say this a lot in this course. We usually prefer to work with nice fractions because fractions are exact. 8/3 is exact. 2.6 is a horrible rounding off of 8/3. 2.66 is also a horrible rounding off of 8/3. 2.667 is also a horrible, not quite as horrible, but it's still horrible, rounding off of 8/3. The exact number is, well, you could get all French about it and put a line over your 6 and say it's 2.66666666666, but come on, that's ugly. That's ugly. Just call it 8/3. Work with fractions, please. Fractions maintain our precision. We like precision. Fractions, not decimals. And like I say, reduce your fractions, but if they're improper, that's fine. While I'm talking about fractions, why don't we do this? Let's verify one of these answers. Which one? Doesn't matter. Let's verify the 8/3. No, let's verify the 4/3. Change my mind. I have a tendency to do that now and then. I'm going to verify that x equals 4/3 is really a solution. Now to do that, go back to the original equation. This is a general habit you want to have. Whenever you're checking a solution, you go back to the original equation and you plug it in. So here's my original equation. So I say, does 8 plus 2 times the absolute value of 3x's, means I'd have to multiply 3 times 4/3 minus 6, close that. Does that equal 12? Question mark. That's the issue. Now in order to figure that out, first you'll have to multiply these two things together. Remember how to do that? You think of the whole number 3 as a 3/1. Next, whenever you're multiplying, you can think about cross-canceling. Those 3's will cross-cancel. So you kind of just go like, 3 goes into 3 once, 3 goes into 3 once. And then when you are multiplying fractions, it's a straight across deal. So 4 times 1 is a 4 on the top, 1 times 1 is a 1 on the bottom. And of course 4/1 is the same as 4. So what I've got inside my absolute value is a 4 minus 6 is a -2. Now here, absolute values are kind of like parentheses, with the exception that you must do it first. You have to actually strip the sign off that thing first. So 8 plus 2, this becomes a regular parentheses with a 2 in it. And by the way, notice that this works. 2 plus 2 is 4, plus 8 is 12. Yes, it works. It worked. So just a reminder of how you play around with these fractions. As an exercise, you may wish to verify that the 8/3 is also a solution. Okay, so let's do a little more of this fraction practice here. Here's a nice absolute value equation. It's got fractions in it. Now remember the key idea. To get started, the first thing you want to do is you want to isolate this part. This part, well, let's see. Somebody's multiplying it by a, not just a 3, but a -3. Somebody's multiplying it by a -3. Someone is also adding this 8 in here. So there's two operations that we sort of have to undo. And you save the dividing for last. First you subtract the 8 on both sides. So the 8 minus 8 will cancel away. Now don't lose that negative. This is -3 times the absolute value of x minus 3/4 equals, okay. Now over here, how do you do this? You think of this as a 1/2 minus, think of the 8 as an 8/1. And then say, oh, I need common denominators, right? So it's multiply top and bottom by 2 here. And I'm going to be looking at a what? A 1/2 minus a 8 times 2 is a 16/2. And so that's a -15/2. Okay, so here we go. -3 x minus 3/4 like this equals a -15/2. Now what? Well, now we're going to want to divide off this multiplier of -3. So it cancels over here. That would be nice. So I've got this x minus 3/4 in absolute value equals. Now, first of all, notice that this is positive, right? A negative divided by a negative is positive, so we can ignore the signs now. But what the heck is that? That is a 15/2 being divided by a 3. That's what fraction bars tell you, that you're dividing by what's on the bottom. So on the top, I got a 15/2. What am I doing? I'm dividing it by 3, which is what we said in the first place, divide both sides by 3. And remember that in order to divide by something, what you actually do is multiply by its reciprocal. So times 3 is becoming, divide by 3 is becoming times a third. This is multiplication. That's the one time you're allowed to try cross-canceling, is when you're multiplying. And so notice I got 5 times 1 over 2 times 1. I'm getting 5/2. This is a 5/2. Cool. Now, I'm going to have to shrink this down because it's getting kind of big here. I need more space. The moderns of modern paper, huh? Oh, what'd you do? Why does it do that? Why do you do that? I had you in the... What? Man, this thing is touchy. Okay, come on, you. Come on, let's do it. Let's do it this time. Stay. Whew. Okay, so... where was I? Oh yeah, so we've got the absolute value isolated. That's good. So now we can say, okay, before I stripped off the sign, it could have been 5/2, but it could have been the negative of that as well. So my one equation is now two equations. X minus 3/4 could be 5/2, but on the other hand, x minus 3/4 could be a 5/2. I've got two cases to worry about here. So adding 3/4 to both sides, I got 5/2 plus 3/4. 5/2 would be the same as, you'd have to multiply top and bottom by 2's here. That'd be 10/4 plus 3/4. And so one of your answers is a 13/4. Over here, add 3/4 to both sides. I got a negative 5/2, add a 3/4. That's the same as negative times 2 top and bottom, 10/4 plus 3/4. And so here I'm getting a negative 7/4. And there are my two solutions, 13/4 and negative 7/4. And I invite you to actually plug them in there and make sure it works. They should work. They should work. One more fraction-y thing before we move on. Yep. Before we move on. This one, I want to show you this one. It looks worse, right? It looks worse, but we can actually save ourselves a lot of grief. There's a nice tip. It's called cancel, or maybe I shouldn't say cancel. What should I call it? Cancel the fractions? I'm just going to call it remove the fractions. We can clear the fractions. That's what it's called. Clear away fractions. Now you can only do this from an equation, not from an expression. You have to have two sides, in other words. Why do you have to have two sides? Because we're going to use the rule that says what you do to one side, as long as you do it to the other, you're fine. What are we going to do to both sides? We're going to multiply both sides by the common denominator, the least common denominator. Look at your fractions. I got a 3, I got a 12, I got a 4 on the bottom. What's the common denominator if you're looking at thirds, fourths, and 12ths? The common denominator is 12. So what I'm going to do now is I'm going to take the entire equation and multiply it by 12. That means I have to multiply the first term by 12. I can say 12 over 1. It means the same thing. I am going to multiply the second term by 12. And I'm going to multiply the other side of the equation by 12. Multiply the whole thing through by 12. That's legal, right? If you do the same thing to the left side as to the right side, it's still a valid equation. What's cool is that now this cross-canceling thing, the 4 cancels into the 12 3 times, the 12 cancels into the 12 1 time, the 3 cancels into the 12 4 times, and lo and behold, all my denominators are 1s. And we don't care about having 1s as a denominator. You don't have to write that, right? So 3 times 3 is 9. That's what that is. Minus, hey, the 12s are canceled. So all I've got left is this part, the 4x plus 1 in absolute values. On the other side, I got 4 times 2 is 8. Now, isn't that nice? Wasn't that a trick worth learning? Aren't you glad you saw this part of the video? You're so glad that you saw this part of the video, because in the future, when you've got equations that have all these fractions in them, you won't have to get out your common denominator thinking cap or whatever you call it. You can just clear the fractions. It's a wonderful trick. Multiply both sides by LCD. Works every time. Moving right along. Now's the part where we say, okay, I'm going to isolate this part. So subtract 9 on both sides, right? So this is a, don't lose that. That's still there, right? It's like a negative 1 out front. It's still there. So I got a negative 4x plus 1 here. Negative absolute value of 4x plus 1 equals. And 8 minus 9 is a negative 1. Now, I still don't quite have it isolated because of that negative there, so I'm going to basically divide both sides by negative 1. Maybe I'll bring this up here. So the negatives cancel on the left. I got the absolute value of 4x plus 1. On the right side, a negative 1 divided by negative 1 is a 1. And now we're at that situation where this, after I strip the sign off, it's a 1. So before I strip the sign off, it could be a plus 1 or a minus 1. This one equation becomes 2 equations. So one of my equations is that 4x plus 1 equals 1, and the other one is that 4x plus 1 equals negative 1. And you just solve these up real quick. Subtract 1 on both sides. Divide both sides by 4. There's a solution. X could be 0. Subtract 1 on both sides. Divide both sides by 4. And please reduce. You can cancel 2's here. So negative 1/2 is another solution. So 2 solutions. You almost always, not always, but almost always get 2 different solutions for these things. Okay, so looking back, what is it that we have learned today? We have learned about clearing fractions from big equations by using the old multiply by LCD trick. That's just a nice handy thing to know. We learned the basic idea of absolute value equations, which is first get that part by itself, and then once you've got that part by itself, you do a little logic. You say, well, after I strip the sign off, it's going to be a 1. So before I strip the sign off, it could have been a +1 or a -1. So if I don't want to have these absolute value bars there, my one equation's turning into two equations. This stuff inside could be a +1 or a -1. Breaks into two equations, you get two solutions. Now, for the big trap. I have to warn you about the big trap. This is a big trap. Big trap. I think it's a purple trap. That's what I think. This is a purple trap. All right. Let's see what happens. First, I was not lying to you when I said that the first thing we should try to do is get this absolute value part by itself. So let's do that. Let's subtract 5 on both sides. Everything is hunky-dory here, right? Hunky-dory. 1 minus 5 is a -4. If you want to isolate this absolute value bar, you're next going to divide both sides by 2. So I got the absolute value of 3 minus 2x like this. And then a -4 divided by 2 is a -2. And then you do the old, well, it must have been the plus or the minus of this before we strip the sign off. Let's make that look like a 2 just to be official here. Okay, cool. And so what is this giving us? Let's come up to here. This is saying that 3 minus 2x could be a plus -2, or it could be a -2, which is +2, of course. Keep solving. -2x. I subtract 3 from both sides. That's a -5. I divide both sides by a -2. The negative over negative is positive. There's an answer. And then this one, subtract 3 on both sides. 2 minus 3 is a -1. Divide both sides by -2. A negative by negative is positive. It's a 1/2. Cool. Ain't that something? Where am I? Looking at my notes saying, wait, that's not the answer I just got. Oh, here it is. Yeah, that's good. That is the answer I got. That's good. Okay, so I said there was a trap. What happened? What's the problem here? I'll tell you what the problem is. These solutions don't work. What? Watch. I'll show you. I'll plug it into the original equation here. 2 times the absolute value of 3 minus, and that says 2 times, and let's just put this value, this solution in the 5/2. See if this one works, which it won't. Okay, well, let's see what's happening here. 3 minus, now remember, this multiplication, the 2 is like a 2 over 1. These 2's are cross-canceling, so you get 5 over 1, which of course is just 5. So it's a question mark. We're checking to see if this works. This is 2 times 3 minus 5 is a -2. Well, you take the absolute value of -2 and you get a 2. You multiply it by that 2 and you get a 4. 4 plus 5 equals 1. Uh-oh. It's not working. It's not working. So why doesn't it work? Well, we made a blunder. We made a big mistake. And this comes back to what I was saying at the opening of the lecture, which is when you're playing with this college algebra stuff, you got to keep your mind, or your eye, you got to keep your eye open at all times. You got to be alert to possibilities of, wait, look at what that says. Look at what, in particular, that says. It says I take the absolute value of something and I get a -2. That doesn't work. Because taking the absolute value off of anything means you strip the sign off. And if you... Oh, look, I got an arrow. That was cool. And if you strip the... Come on, you. If you strip the sign off, how's it going to be negative? You said you strip the sign off. How's it going to be negative if you strip the sign off? It can't be. This is impossible. This is actually an impossible statement. It cannot work. That means the equation cannot work. That means this equation has no solution. That is a symbol, by the way, for empty set, and it's not the number 0. Please don't use that for the number 0. It's not the number 0. It's something else. It means a set with nothing in it. It means, hey, gather together all the solutions. Well, there aren't any. The set's empty. So you might write empty set this way, just a set with nothing in it. Or this is a circle, not a 0, but a circle, not an O, but a circle with a slash through it. That means empty set. It means no solution. These are all, you could of course just write no solution. It means the same thing. There is no solution to this thing. It has no solution. And it goes back again to right here. You said that when I took the absolute value of this stuff, it would be -2. It can't be. Taking the absolute value means you strip the sign off. If you strip the sign off, it can't be negative. It can't be. This cannot have any solution. And that's why when we thought we were finding solutions, we plugged them in and said, hey, it doesn't work. That doesn't work. It doesn't work because there are no solutions. Okay, so that's a big trap. Make sure you don't fall for that. Make sure you're alert to that. Keep your eye out for that. If you ever run into this situation right here, the absolute value comes out negative, you can stop working and say, no, there's no solution here. This is a PS. This is kind of on the same theme, but let's see, we wanted to solve this one, right? We'd want to get this by itself, so we'd subtract 5 on both sides. Now, don't forget, this is like having a -1 in front. So that's there. Anyway, the 2 minus 5 is a -3. And what I want to warn you about is don't get jumpy. Don't get jumpy and say no solution. Why not? Doesn't this say that the absolute value is negative? Not quite. We haven't actually isolated our absolute value bars yet. We haven't actually set it yet. What we have to do next is we have to, maybe I'll go back to blue. We have to, in order to isolate that, we should divide off. This is like having a -1 in front. We should divide off the -1 on both sides. And guess what? Now what we're looking at is something that can be solved. I won't do it here. You get the idea. It can be solved. So be a little careful. It's like, yes, I'm trying to say if the absolute value stuff comes out negative, stop. There's no solution to that equation. But again, don't get too jumpy. You haven't isolated the absolute value yet. There's still a negative here. Those two negatives are going to cancel. Yes, you are going to be able to solve this one, okay? So it's kind of like two warnings for one. You got a 2 for today on warnings. Speaking of warnings, we'll end this lesson, end this lesson with 3 common blunders. I see these a lot. So if you're tempted to make one of these, maybe I can stop you, prevent you from making that mistake. So this first one, haven't we been saying for like a long time now that what the absolute value bar does is it strips the sign off so that, for example, the absolute value of -2 is just 2. That is correct. That is what it does. Does that mean that if I put an x there and I take the absolute value of -x that I'm going to get... Oh, I wrote that wrong. I wrote that wrong. Sorry. Let's go like this. That's what I meant to write. So, is it true that the absolute value of -x is just x? So again, like I was saying, the absolute value of -2 is 2. That's right. So why can't we say the absolute value of -x is x? The reason we can't say that is because it doesn't always work. If it was true, it would always work. If I can find one situation where it doesn't work, then I have to say it's false. You can't say it's sometimes true. That doesn't count in math. Sometimes true doesn't count. If it's ever false, the whole thing's false. So if x is -1, what does this say? It says I have the absolute value of, I'm replacing the x with a -1 on both sides, right? You said x is -1. You said x is -1. Okay. Well, this is a -1, which is a 1. And you find out very quickly, this is not working. So if x happens to be a negative number, it's not working. So you cannot say that, so just kind of don't. So what I will say here then, I will summarize this idea in like a fuchsia, is I will say, don't say that the absolute value of -x is x, since it won't be true if x is some negative number. You can say that the absolute value of -x is the absolute. That works. Actually, that works okay. That part works okay. This is the part that doesn't work okay. Okay, so be careful about doing that. Please don't do that. Okay. What's going on in this other one over here? Well, I see this a lot. Somebody has this 5 minus the absolute value of negative x, and they say, well, I guess I'll just do the old, negative times negative is positive, and so it's 5 plus. Okay, no. You really cannot do this. Do not distribute negatives. And the same thing would go for factoring out negatives. Do not distribute negatives into abs values. It does not work. What you have to do here is you have to first, let's say, for example, we had something like, instead of looking at the x, let's look at like a 2. Just make up something like a 2. This is often how you can check that things are false. You just say, well, if this were a number, what would happen? Would this work? Well, this is a 7, obviously. But is this a 7? That's not a 7. Because you have to first strip the sign off of that. You got a 5 minus 2. This is a 3. This is not a 7. Okay? So again, the main point is, please be careful that you don't do this. Do not distribute negatives into absolute values. They don't work like normal parentheses. They're special. They are special, man. You got to treat them special. And then this one, I've seen this before. That's why I put it there. I guess the thought is, hey, doesn't everything negative become positive or something? And it's like, not really. And to show that it's not true, you just look for a counterexample. Just make up any number. Try x equals 2. Well, the left side would be a 2 minus 2, and the right side would be a 2 plus 2. This is a 0. This is a 4. That doesn't work, right? If you can find any one counterexample, maybe I'm going to write this down because this is an idea we're going to run into some more. If you can find any counterexample at all, counterexample means, see, it doesn't work. It doesn't work when you use a 2. That would be called a counterexample. If you can find any counterexample, the whole thing is false. The whole statement is false. Sometimes true doesn't cut it in most math contexts. I want to say all, but I've become paranoid enough that I never say all. Never say all. You got to be so careful with math. Math will make you paranoid, but it's a healthy paranoia. It'll make you keep wondering, am I really right? Am I really right? I really should think hard about this. Am I really right? Well, if I try x equals 2, no, that doesn't work. So no, I can't do that, It's a good habit. Just if you think something might work, well, try plugging in a number. You might soon discover, no, that doesn't work. Can't do that. But anyway. Okay, so absolute values. Welcome to absolute value land. Alrighty, nice. We're back. We're swinging in the groove now, huh, folks? Let's do some more algebra tomorrow. What do you say?